Okay, in this video lesson, we're going to talk about the other major type of reactions that we can get when it comes to energy, and that is our exothermic reactions. Okay, so the other day we talked about endothermic, where energy was going in. In this scenario, we have exo, and exo means out. And again, thermic still means heat, so we're talking about heat leaving, okay, which means that energy is coming out of the bonds and going into kinetic energy. So because we're letting heat leave, we now can feel that heat and it will warm up or feel hot to us, okay? So when we have this happening, we're going to see a temperature change to increase because unneeded energy from the new bonds released to become kinetic energy, okay? So if you can imagine, this is kind of like you have money in your savings account and you take it out of your savings account and now you are going to spend that money as you are working with whatever you want to spend your money on, okay? So in this case, if you think about it, we're going to have our potential energy eventually is going to start up high because we have a lot of money in our savings account. We have a lot of potential energy saved up. And then we make a change, then we're going to use up this stored energy, and now we don't have as much of it, and then we're going to release it as kinetic, okay? So you can imagine in our system that energy is going to go out. And as energy goes out, things are going to warm up, okay? So again, if we use our money analogy, we're going to take this idea that you're withdrawing from the savings to go ahead and spend that, whatever you had saved up, okay? So exothermic reactions are exact opposite of the endothermic reactions we studied the other day. Now, if we look at that through our graphical information again for exothermic, again, we want to remind ourselves that we're talking about the potential energy here. We're not talking about heat energy. So these graphs map the stored energy in the bonds, as that's what our focus is what's going on inside these bonds of these molecules, all right? So we see that we have hydrogen here and oxygen here, and before they react and become water, they have a lot of bond energy. And then as they react and they turn into water, they're going to release this bond energy. So they're going to release energy, and they're going to have a new energy which is much lower than the original energy. So see how this line is lower than this line? So this line is higher, this line is lower. So there's an energy change that drops and releases energy. So when you have a release of energy, it has to go someplace. And where it goes, well, it's got to go to kinetic, all right? Right? It's just like if you have extra clothes in your drawers, it has to go someplace. So maybe you donate it away. You're not going to hold on to those clothes anymore. They don't fit you. They're too old. They're not in style, whatever that happens to be. But they have to go somewhere. So there has to go to someplace else that will use them. Same thing here. If these bonds don't need the energy, it has to go somewhere, and it goes to kinetic. So for exothermic reactions, we have a releasing of bond energy to make less, and then that release then goes out to warm up our world, okay? So all of our exothermic reactions are going to have our triangle on this side of the equation because we're showing that the energy is being released and that energy goes out to warm up the world around it, okay? In these scenarios, right? So if we have endothermic and we have exothermic, the other day we did the lab with cold packs. The exact opposite can actually be true also for hot packs. So we actually have those hand warmers. Maybe you've used them at a hockey game or a football game, or maybe you've gone outside in the cold and you can tear those little packets. You shift them around and you shake them and they kind of feel kind of gritty in your hand. You can buy them kind of cheap at gas stations and in grocery stores and Targets and stuff in the wintertime. And all you need to do is open them up and shake them and they get hot, okay? It's the same concept, but it's the exact opposite of endothermic. When you shake them together, what you're doing is releasing two chemicals, or three or four chemicals actually in this case, that combine together now result in an exothermic reaction, and that exothermic reaction releases heat energy, and then we of course put our hands on it to keep us warm, okay? So we will do a lab with hot packs also coming up shortly. But that is the video lesson for today on exothermic reactions.